So today you get to start your journey in the Algebra 2 course. The first unit in Algebra 2 is basic knowledge. As we're doing these notes, I would encourage you to write them down. Please write them down. Brain research has shown that as you write things down, it's easier for you to remember things. So make sure you're taking notes. It's going to make the lessons and the homework a lot easier for you. It's a lot easier to ask meaningful questions when you actually see us in class. So make sure you're taking notes as I go through the lesson, and hopefully that will be all you need to be able to be successful. So let's talk about the real number system. The real number system is all of the numbers that you have ever talked about from pre-K through where you are now. So any number that you have ever dealt with so far is part of the real number system. But that real number system can be broken down into several different parts. And basically, when I teach this, I tell my kids, let's think about a chicken. Okay, this is kind of a weird way to explain it, but when I started explaining it this way, more of my kids were able to retain the information. Okay, so think about a chicken. I'm going to let that chicken represent the entire real number system. That real number system can be broken into two different parts. The real numbers can be broken down into rational numbers and irrational numbers. Let's think about the chicken. What are the two things that will come out of a chicken? One of the things that comes out of a chicken is very useful, an egg. Okay, so I'm going to draw that egg here, right? Another thing that comes out of the chicken, if you think about it, is the messy stuff, the poo, the stuff that nobody wants to have to deal with. If you've ever had a chicken coop in the backyard, nobody ever likes to deal with the messy stuff that comes out. Nobody likes to get that stuff out of the coop, okay? It's not so bad to gather the eggs, but it's not good to have to do that, okay? So the poo is going to represent the really nasty numbers, the numbers that nobody likes to deal with. And the egg, it's separated into several different number systems that aren't so bad to deal with. There are a lot of things we can do with those numbers, and you're going to see a lot of uses for those, okay? So the egg is going to represent the rational numbers, and the poo represents the irrational numbers. Okay, so we're going to deal with the numbers that come out of the real number, or the rational numbers first, and then we will deal with the irrational numbers, okay? So what I want you to do first is think about an egg, okay? I'm going to boil that egg, I'm going to hard boil it, and then I'm going to slice it in half. Without peeling it, I'm going to slice it in half so that I kind of have an idea of what's going on inside of that egg. Now, if you think about it, it has several parts to it, okay? The most center part of the egg, if you think about it, is the yellow part, or the yolk, okay? Outside of that yolk, we have the egg white, okay? So I'm just going to put that outside of there. And then if you think about when you peel a hard-boiled egg, just inside the shell, there's that real thin, it's like a paper thin, I call it a membrane, but it's just a real thin layer inside, just inside of the shell, okay? So I'm going to draw that in. And then the last layer is that actual hard shell on the outside of the egg, okay? This doesn't have layers, it's just all messy and gross. All right, so we're going to talk about these layers and how they're represented as a part of the rational numbers, and which is also considered a real number, okay, and how they relate to each other. All right, so we're going to start with the innermost set of numbers, okay, and that set of numbers is going to be called the natural numbers. All right, so write this down. The definition, well, natural numbers, and this is not a proper definition, but this is just how I remember it. The natural numbers are the numbers it's natural to start when you count, okay? So let's say you're playing hide and go seek as a little kid, and you're it, and you have to count. Well, what was it natural to start with? It's natural to start with 1. So the natural numbers are the set of numbers that it's natural to just start counting with. So 1, 2, 3, and that does go on to infinity, because you can count as long as you want to. You get tired of it, but you can count forever, okay? So the natural numbers is the first set of numbers. We're going to use the yolk of the egg to represent that set of numbers. So this is the natural number system. It is the smallest number system. It has the least number of numbers, but still there's an infinite number of numbers within that system, okay? Now, the next number system, I'm going to use the egg white to represent that number system. And notice the egg yolk is completely surrounded by the egg white. What that means is this is representing a Venn diagram, okay? Anything that is completely surrounded by the next level is also considered a part of the next level. So the natural number system is not only a part of this number system, it will be a part of this one, and if it were inside the egg, this one, or inside the chicken still, this one, okay? So the natural numbers, and I'll just go ahead and say 1, 2, 3, ... represented by the yolk, okay? The next set of numbers is the set of whole numbers, okay? Well, the only number that is a whole number that is not also considered to be natural, and you probably already know this, is 0. So the set of natural numbers and 0 are considered the whole numbers. Now, I always tell my students, how can you remember that? Well, if you dig a hole in the ground, what number does it look like? Well, it's an O, it's a 0. Okay, so if we dig a hole in the ground, it's a circle, it's an O, it's 0. Whole numbers start with 0, and they contain all of the natural numbers. Okay, so the only number that is in the set of whole numbers that is not also natural is 0. So the set of whole numbers is 0, 1, 2, 3. Everything else that's inside that egg white is considered whole as well. Okay? The next set is the set of integers. The set of integers, hopefully you already know this, but the set of integers is the set of whole numbers, so all the whole numbers and their opposites. Well, let's talk about what opposites are because that's important. Opposites are the negative of the number that you were given. So the opposite of 1 is -1. The opposite of 2, -2. The opposite of 3, -3, and so on. Well, what's the opposite of 0? We haven't talked about that. Well, 0 is neutral. It's neither positive nor negative. So it is its own opposite. Okay? So 0 is also considered an integer. And to represent that, I would put ... because it goes forever in the negative direction. 3, 2, 1, and those are negatives. 0, 1, 2, and 3. Put the dots to signify that it does go on forever. Okay? So this is the set of our integers. The set of integers, I'm going to use that little teeny shell membrane, or that real thin, paper thin membrane as my integers when I'm talking about the egg. Now, keep in mind, as you're peeling that hard-boiled egg, that shell membrane is completely surrounding the egg white, which is completely surrounding the egg yolk. So, all natural numbers are also considered integers. So what are the only numbers considered integers that we haven't talked about? Well, all of the negative numbers. The next set of numbers we have to deal with are the rational numbers. It's important that you understand the definition of a rational number, okay? And keep in mind, rational numbers and irrational numbers are opposites, okay? So their definitions will be opposites, all right? So by definition, a rational number is any number that can be written as a fraction. Any number that can be written as a fraction. Well, let's think about that. Can natural numbers be written as fractions? 1 over 1, right? 5 over 5, 10 over 10. Anything over itself would be considered 1. 2 over 1, 4 over 2, 10 over 5 would all be considered 2. So natural numbers can be written as fractions. 0 over 5, 0 over 10, 0 over -3, 0 over 2. It can be written as a fraction. Negative numbers. Well, -2 is -2 over 1. -10, -10 over 1. So all of the numbers we've talked about so far can be written as fractions. So they are part of the rational numbers. Okay? But what numbers have we not talked about yet? Well, those are the fractions that are not also considered whole, natural, or integers. So like 1/5. Well, 1/5 is a fraction. So this is where your fractions come into play that can't be simplified into like a simple number, okay? Simple whole number or integer, all right? So 1/5, 2/5, 3/10. I know there's an infinite number of fractions I could use. Negative fractions, -2/3, -1/8. All of those would be considered rational numbers. What else could we have? What other type of number could we have that could be written as a fraction that we haven't mentioned yet? Think about decimals, okay? Decimals like 2.5. Well, 2.5 is 5 over 2 if we write it as a fraction. If you put 2.5 in your calculator and hit the F to D button, it will convert it to a fraction for you, 5 over 2. So any decimal that can be written as a fraction is going to be considered a rational number, okay? Well, what other type of decimals have we not considered? Think about repeating decimals, okay? And one in particular that I want you to think about is 0.3 repeating. Do you know, can that be written as a fraction? And hopefully, as you've learned your math so far, that has come up enough for you to understand that 0.3 repeating is 1/3. Because if we take 1 and divide it by 3, it will give us 0.3 and it keeps going. It will just keep going and never have another number after the 3. So that is a repeating decimal, and it can be written as a fraction. Now, I can't show you why yet, but all repeating decimals can be written as a fraction. We will learn that later in this course when we get to series, okay? This is actually considered an infinite series, and there is a formula to find the fraction when you're given an infinite series like that, okay? So we'll learn that later. For now, you'll just have to trust me. All repeating decimals can be written as fractions, okay? So rational numbers are decimals, yes, like 2.5, 0.5. Repeating decimals like 0.3, 0.6, repeating 2/3, right? So all of those numbers are considered rational. Now, as I mentioned before, irrational numbers are the opposite of rational numbers. So, by definition, if a rational number is any number that can be written as a fraction, an irrational number is any number that cannot be written as a fraction. So it cannot be written as a fraction. Well, let's think about what kind of numbers can't be written as fractions. If you have a non-terminating decimal that never ends and it never repeats, okay? Like, I'll just make something up. 8.1241867 It keeps going. That never ends, it never repeats, it's considered non-terminating, okay? That is an irrational number. It's a really messy number. Nobody wants to have to deal with that on pen and paper or pencil and paper, right? We don't want to have write that down and do anything with it, add, subtract, multiply, or divide, or any form of those things, okay? It's too hard. You got to have a calculator to deal with a number like that, okay? And you'll see more and more numbers with that as you go further in your math career, but luckily with those, we'll be using a calculator for all of those computations, okay? But that would be considered an irrational number. So that would be a non-terminating decimal. Now, what other number have we not talked about that shows up a lot in geometry when you dealt with circles and the area and circumference of a circle? That awful number pi showed up, right? So pi, 3.14, and it keeps going forever. It never ends, it never repeats. Pi is considered an irrational number. Okay, so now I want to do some guided practice with you to make sure you understand how to answer questions as they're presented. So let's just suppose I give you a number like 3, okay? And the directions are going to say list the set of numbers that each number is a part of, okay? Well, we know every single number that I will give you is going to be a part of the real number system. So you don't have to use real number. You don't have to write that down. That is assumed, okay? We know every number you're dealing with today is going to be real. But what we can do is distinguish which of these it is a part of. It's asking for you to state all of the number sets that it's a part of, okay? So, for numbers that are within the egg, okay, and I'm just going to use 3 as an example. Well, you have to consider, is 3 a natural number? Is it natural to use 3 when you're counting? Yes, it is, okay? 1, 2, 3. It comes up pretty quick, okay? So 3 is a natural number, all right? So if it's natural, I'm just going to use an N to represent natural, okay? You don't have to write the whole word out, all right? Well, if it's natural, let's think about that. Weren't all natural numbers also considered whole numbers? Didn't we say that? The only number that's whole but not natural is 0, okay? So anything that is in the yolk, anything that is natural, has to be a part of all the other number systems within the egg. Not the poo, but within the egg, okay? So we will work our way out. We will figure out what the first number system is it shows up in, and it will be that and anything to the outside of it. Okay, so 3 is natural, it's whole, so I'll use a W for whole. It's an integer. I use INT for integer. Don't just use I, because I might not know if you're talking about an integer or irrational. So INT, and it is rational. I use RAT for rational because real starts with an R, okay? And we want to distinguish between all of our number systems. You do not have to put real. All of the numbers that we're talking about will be real, okay? All right, let's talk about another number. Let's say -8, okay? -8, well, it's not natural to count and say -8. It's not going to be a whole number because the only extra number that's not natural in the whole numbers is 0, okay? Integers is where negative whole numbers come into play. So, -8 is an integer, and since it's inside the rational numbers, it's also considered rational, okay? Let's talk about 6.7 repeating. 6.7 repeating. Well, we talked about earlier how repeating decimals can be written as fractions, okay? So we just need to decide. We know it's going to be rational, but is it any of the other ones? Well, it's not natural, it's not whole, it's not an integer. It starts with the rational number system, so it would just be rational. We won't say anything else about it, okay? Now, here's where some students get confused. They say, okay, it repeats, it never ends, so it must be non-terminating. If it's non-terminating, it's irrational. But she also said it's rational, so it's going to be rational and irrational. That's impossible, because remember, by definition, rational numbers and irrational numbers are opposites. You cannot have a number that is both of these, okay? It will either be rational or irrational, can't be both. So, since we said repeating decimals are rational, that's it. We stop there. It is not anything else, okay? So, 6.7 repeating, rational. Let's talk about 3.14. This is one that a lot of kids look at and they say, oh, 3.14, well, that's pi. Don't assume it's pi, okay? It doesn't say that it's pi. It just says 3.14. Well, that is 3 14/100 if we write it as a fraction, which is 7/50, right? 3 7/50. That can be written as a fraction. That is rational. And it started with a fraction, so it's not going to be any of the others. Okay? So I just want to distinguish between some little things like that. Don't ever assume it is anything that it's not. That does not say pi. It says 3.14. All right, what about pi? There, I give you the number pi. Well, it's not any of these. It cannot be written as a fraction. It is irrational and nothing else. I use IRR for that. IRR would be fine. Okay? How about, I don't know, let's do negative 1/3. Negative 1/3. Well, it's not natural to say that when you're counting. It's not whole. That's not an integer. It's a fraction. That fractions don't show up until rational numbers. So that's rational. How about 0? If I gave you 0, I'd ask you to tell me what number systems it's a part of. But it's not natural. It's whole. Since it's whole, anything within the egg outside of where we started would also be considered one of the number systems. So it's an integer and it's rational. Okay? So now I'm going to put some up and I want you to try them. Okay, so here are some examples. It says name all sets of numbers each belongs. Okay, so I give you some examples. What I want you to do now is pause the video and see if you can get these right. Name all the number systems that each of these numbers is a part of. Let's talk about the answers and see how you did. 2.8. Well, 2.8 is a decimal. It's non-repeating, but it is terminating. That means it can be written as a fraction. So that one is rational. 0, we did that one earlier. 0 is a whole number. That's where it starts. It's an integer, and it's rational. 1/6 is a fraction. Anything that can be written as a fraction is rational. 5, it's natural to use 5 when you're counting. So it's a natural number, and it's everything else outside of or within the egg there. So it's natural, it's whole, it's an integer, and it's rational. -2. Well, it's not natural to use -2 when we're counting. It's not a whole number. Negatives start with integers, and it's an integer, and it's rational because it can be written as a fraction. Okay? -3 1/3, that would be only rational. 2.5 repeating, okay? We said repeating decimals are rational, not irrational. All right, this one, that one looks pretty messy. It's got that ... signifying it's non-terminating. If it's non-terminating like that, it doesn't repeat. There's no way to write it as a fraction, so that one must be irrational. 0.6 is another repeating decimal, so that's rational. And then here's something interesting. It says pi plus 8. Well, if we take those things separately, pi is irrational, 8 is natural whole integer rational, but if we add those two together, it is going to be an irrational number. It never ends, it never repeats, okay? So that would be irrational. If I gave you something like 8 pi, that would be irrational. Anything containing a pi will be irrational, okay? I hope that helps you understand the real number system.